Hello everyone, I am Dr. Hend, researcher in National Research Institute of Astronomy and Geophysics. It's a pleasure to introduce to you our research entitled Electronic and Physical Studies for Teflon FEP as a Thermal Control in Low Earth Orbit, reinforced with zinc oxide and silicon dioxide nanoparticles, with authors Professor Maruf Hijazi and Professor Rasha Ghunem. Let's start with our overview, which consisted of introduction, computational details, building model molecule, interaction of Teflon FEP with different metal oxides, quantitative structure activity relationship calculations, then our conclusion. Let's introduce our work. Nanotechnology is an important branch of science used nowadays in various applications. A new trend of applications is nanotechnology for aerospace. The importance of nanotechnology for aerospace divided into preparing materials that have unique properties as low weight, high resistant to extreme conditions, high strength. Used for various applications, sensors, coatings, X-ray shielding, solar cell application, gas storage, optoelectronic materials, UV sensing, adhesive applications, fuel cell capacitors, corrosion inhibition. There are some polymers used in space such as Teflon FEP, Kapton polyimide, polymethyl methacrylate. This polymer exposure to a reversal of incident photons, atoms, and vacuum ultraviolet ions. Teflon FEP is an external surface of multi-layer insulation blankets on the Hubble Space Telescope, which is suffering from cracks in space with time. So we supposed our work to enhance the surface of Teflon FEP with some nanometal oxides. To study our work, we used Gaussian 09 program to calculate the interaction between Teflon FEP and some metal oxides as zinc oxide and silicon dioxide, and a combination of the two metal oxides. All models computed using density function theory at the P3 lab level using the LAN L2DZ basis set. Homo-LUMO band gap energy, total dipole moment, and molecular electrostatic potential as contour were calculated at the same level of theory for all structures. Also, quantitative structure activity relationship calculated using semi-empirical BM6 level. To build our model structure, we have to study the active side of Teflon FEP. By interacting Teflon FEP with zinc oxide, different active sites as position 1, 2, 3, and 4. By calculating the band gap energy, the most probable active site of the interaction is position 3. From previous result, we studied the interaction of zinc oxide and silicon dioxide and the combination of the two metal oxides layer by layer with Teflon FEP through the active side of position 3. By calculating Homo-LUMO orbital distribution and molecular electrostatic mapping, the result indicated that metal oxides enhanced the electronic properties of Teflon FEP and reactivity. Also, result of total dipole moment and band gap energy confirmed the enhancing of metal oxides, and the most effective metal oxide was the combination zinc oxide silicon dioxide layer by layer or as sandwich with band gap equal to 0.2 electron volt. Also, quantitative structure activity relationship calculations, which study the reactivity and stability of chemical structures by calculating some descriptors such as total energy, heat of formation, ionization potential, log P, polarizability, molar refractivity, and molecular weight. From all data, the most reactive and stable structure was Teflon FEP, zinc oxide, silicon dioxide layer by layer. So we can conclude our work. Model molecules simulate Teflon FEP and Teflon FEP interaction with nanoparticle zinc oxide, silicon dioxide, and a mixture of both metal oxides were subjected to density function theory calculations at B3lib LAN L2DZ basis set to understand the changes in electrical properties, HOMO-LOMO orbital distribution, molecular electrostatic potential as contour, and even thermal stability properties using quantitative structure activity relationship descriptors. Teflon FEP and metal oxide coatings such as zinc oxide and silicon dioxide recorded that Teflon FEP, zinc oxide, silicon dioxide layer by layer improves all stability parameters for Teflon FEP that make it a significant upgrade for Teflon FEP as a corrosion inhibiting layer that is damaging while space mission. Finally, I want to thank you all for attention and I am waiting for any questions.